guys, it's Mrs. Milson. Okay, let's do the check your understanding on page 40. Okay, write a few sentences comparing the distributions of resting and after exercise pulse rates in figure 1.9. All right, figure 1.9 is the previous page. Here you go, figure 1.9. Back-to-back stem plots of 19 middle school students resting pulse rates and their pulse rate after 5 minutes of running. Okay, we'll look at our key. So 8/2 equals 8.2, so this would be 146 beats per minute. This would be 68 beats per minute. Okay, so let's do a comparison. So we got to go through socks, okay, but use some comparison words. All right, so shape. Okay, that's the first S of socks, shape. All right, I'm going to turn this sideways. We always look from the smallest to the greatest. So this shape is definitely right skewed. And if I flipped this one up, this would also be right skewed. Okay, so I'm going to say both distributions for pulse rate are skewed right and unimodal. The resting pulse rate has a peak in the 70s, and the after exercise pulse rate is higher, or the peak of the after exercise pulse rate is higher in the 90s. Okay? I'll show you my paper after I finish saying everything. Okay, so that's shape. Outliers. Let's see. They both appear to have a high outlier. The person that had a resting pulse rate of 120 beats per minute seems to be the outlier for the resting pulse rate distributions, and the student with a after exercise pulse rate of 146 beats per minute seems to be the outlier for the after exercise pulse rates. Actually, let me show you that for each one. Okay, so here's what I wrote, excuse me, for shape and outliers. Okay, if you want to take a second, those are the things I just said. I'll stop talking so you can read that. Okay. Now the next part of socks is center. So it said there are 19 middle school students. So same 19 kids resting and then after exercise. So the center is going to be the middle, the median. So 19. So I got to count in what? 9 and 9 is 18. So it's going to be the 10th one. Okay, so I'm going to start at the bottom and count to the 10th one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the typical pulse rate for the resting group is 76 beats per minute. Okay. And then the typical pulse rate for the after exercise, so again, I'm going to start at the lower and count in 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The typical the typical pulse rate for after exercise is 98 beats per minute. Okay? So again, there were 19 observations. So the middle one is the 10th observation because 19, I'll count in 9 and 9, which is 18, and then the 10th one from either end will be the middle observation. So the resting pulse rate median was 76, the after exercise pulse rate median was 98, and these are the typical values. So I just said the typical pulse rate for after exercise is higher than resting. Okay, I could have said the typical pulse rate for resting is lower than after exercise. It doesn't matter. Just use a comparison word. Higher, lower, whatever. Okay? All right, the last thing is the last S for spread or variability. So let's see. The resting pulse rates vary from 68 to 120. And then the after exercise pulse rates vary from 86 to 146. So did a little calculation here. For the resting from 68 to 120, that's a difference of 52 beats per minute. And the after exercise from 86 to 146 is a difference of 60. So they're not too different, but clearly the after exercise, the distribution of after exercise pulse rates has more variability than the distribution of resting pulse rates, simply because that difference is greater. Okay? And yes, you could have said the variability for resting is less than after exercise. I don't care. It doesn't matter. Just make a comparison. Okay, I want that greater than, less than, different, same, higher, lower, those comparison words. Okay, so this is our complete comparison. Socks. Okay, and I stuck in the variability too with spread. Okay. Next question. Let's see, multiple choice. Oh, multiple choice is fun. Here's a stem plot of the percent of residents age 65 and older in the 50 states and District of Columbia. Okay, so I instantly know there are 51 observations in this stem plot. Okay, so just keep that in mind. The low outlier is Alaska. Low outlier. So these are our low numbers. These are our high numbers. There's my low outlier. So 6-8 represents what? 6.8% of the population. So there we go. That's B. Okay. Ignoring the outlier, so we'll ignore him. And don't ignore the outlier unless you're told to. Okay. The shape of the distribution is what? Well, if I ignore the outlier, it does look, I think, roughly symmetrical. If I had had the outlier there, I would have said slightly skewed left, okay? Because again, you're always going to think about it like this, from lower to higher, slightly skewed left, but without the outlier, I would definitely say roughly symmetrical. Roughly, okay? So I would say E. And then the center of the distribution. Okay, center. So again, I have 50 states and the District of Columbia. So there's 51 observations. My sample size N is 51. So where's the middle of 51? So I got to count in 25 and 25. So 25 and 25. And then the 26th one will be the middle. All right, so it doesn't matter. I can count from either end. I always count from the lower end. So 26th one I'm looking for. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So it's that last 8. So 12.8% is the middle observation in this distribution. So that would be C. Okay, and remember when you're counting in, always count from low to high. Like don't do 8, 8, 9, 7, 8, 0, 6, 6, 5. You know, start from the low and go up. Okay. All right. I hope that was helpful, and I'll see you next time.